All right, so taking a look at using these ideas, we're going to start by answering these questions. Go ahead and write down that equation. Everything that we're going to be doing for this first problem is based off of this same equation. We'll be using it a lot. And so you'll notice why we get the graph we do, because it's just an x squared graph that's been moved down 5, so that's why we're starting down 5. The visualization is just there to kind of help us see what's happening. All right, so the first question then is that if x is 2, what is the y value? Now, you can get that two different ways. You could just look at the graph and look to see, okay, where x is 2, what's y? Or you could actually plug 2 into the equation and do the math. Either way, you're going to get an answer of?
Negative 1.
Negative 1. Okay, so if x is 3, what's y there?
4.
It is 4. And so that tells me that this graph includes the points 2, -1, and 3, 4. Oftentimes, you'll be given the problem just in those terms of x's, and so the first thing you do then is you figure out what the y values are, so you can then use them in the work that follows. Because what we're going to be doing is we're going to find the equation of the secant line that passes through those 2 points. I've actually drawn on the graph here that secant line, so you can see it drawn on here. So this is the equation we're finding. And we're going to be working a lot with secant lines and tangent lines here through this particular unit. And in fact, for part of it, the whole rest of the year. All right, so we want to find the equation of the secant line passing through those points. Notice, the fact that it's the secant line just means it goes through 2 points. So if I want to write the equation of this line, I just need to know the coordinates of those 2 points. So really, this whole question just boils down to take that point, take the other point, write the equation of the line through those 2 points. That's all you got to do. There's 2 different ways that we can approach this problem, or at least I consider it 2 main different ways that people approach it. I'm sure there's others that you might use. The first way is we're just saying, I know I'm going to end up with an equation that's going to be y equals mx plus b. So I'm going to start by figuring out what m is. That is the slope. Okay? The slope, remember that's rise over run. And so my rise is going to be like y2, I'll do this one first, minus y1. So 4 minus -1. Over x2 minus x1. Rise over run, right? So we can then go ahead and figure out what that is. You notice that if we do that on the top, 4 minus a -1 gives me 5. 3 minus 2 on the bottom is 1. 5 over 1 is just 5. So our slope is 5.
Now we have to figure out where.
Okay, now we need to find the b value. And this is where our different strategies tend to diverge here. One strategy is that we can go ahead and plug that into y equals mx plus b. So y equals 5x plus b. Then choose one of the points, doesn't matter which one you choose, I'll choose the first one, and plug in the x and y coordinates from that point. And solve it. And so 5 times 2 gives me 10. I then subtract that 10 from both sides. We end up with -11 equals b. The other method that you might use is using point-slope form to your advantage. Now, point-slope form is something that came up quite a bit in Algebra 2, but it is kind of a niche form, but its usefulness, it really comes up best in this kind of a problem, where we can go y minus the y coordinate of one of the points. Again, we'll use the first one, so it'll be y minus a -1 equals the slope times x minus the x coordinate of that same point. And so we can solve this one out. And so the y minus a -1, that's the same as y plus 1. And I distribute the 5 in, so that becomes 5x minus 10. I then need to subtract the 1 from the left side and put it on the right side, so it ends up being 5x minus 11 for that reason. So you notice if I do it using point-slope form, yes, I just found out the b value, but I did so while also getting the whole equation, because that's going to be our final answer. Whereas if you do it using this method, you figure out b, but then you have to plug that into the equation to get the final answer there. But this is what we should be looking at. Y equals 5x minus 11, that is the equation of our secant line. Now taking a look at the graph, then remember that we are finding the equation of the secant line through those 2 points. That is where x was 2 and where x was 3. Notice that blue line drawn through them goes right through those 2 points. And that's what we just found. We found that equation, y equals 5x minus 11, for that line. Okay. If we can do that, then we can also do it with less pretty numbers, such as this. We're going to find out what the equation of the secant line is that passes through x equals 2, so same x equals 2 there, and x equals 2.5. So, see how well you can apply the method we just used to this problem. Because theoretically it's doing the exact same thing. Now as you're working on it, basically this then is the series of steps that you're going to be using. Find the y-coordinates. Now, in this particular case, I wouldn't recommend just looking at the graph for the x equals 2.5. Take it and plug that in for x in the equation, then you can find out exactly what that y-coordinate is. Then you'll be able to calculate the slope, and then you can find your y-intercept from there. So this is our process. Go ahead and go through it. And so for step 1, find the y-coordinates. Well, we already know the first one. If x is 2, we already know that y is a negative 1. We did that last time. If you forgot, you could always plug the 2 in here. 2 squared, 4 minus 5 is negative 1. And then we do it with the 2.5 as well. Plug 2.5 in for x. 2.5 squared is going to give me 6.25. 6.25 minus 5 is 1.25. Then we can go ahead and go on and start finding the slope. Remember slope? That old rise over run? The slope m equals y2 minus y1. Oops. There we go. Over x2 minus x1. And then continue from there. All right, so now that we've done that calculation, we find that m equals 4.5. Side note, some of you are going to see this as a decimal and you're like, wait, slope should always be written as a fraction, right? Yes, you can do that. You could write this as 9/2, but you don't have to. In fact, we're going to be seeing some problems where decimals are going to become the norm when working with these types of problems. So either way is going to be fine. All right, and then you just need to figure out what is that y-intercept. And again, I think most people are doing it by going y equals 4.5x plus b and plugging in a point. That works. And so then that would be negative 1 equals 4.5 times 2 plus b. And so 4.5 times 2, that gives me 9. Subtract the 9 from both sides, we get a negative 10 equals b. Therefore, our final answer is y equals 4.5x minus 10. So we found equations of secant lines, but there was one other piece at the start of class. Remember, you took notes on secant lines and tangent lines. So we want to be able to estimate the equation of the tangent line to this equation. Now, just from the equation, that can be very challenging to do, but visually, from the graph, it's a lot more doable. And so a great strategy is to actually see the graph in front of you and draw it on. So I want to see where x is 2. Okay, so that's going to be this point on the graph. The tangent, remember, just touches the graph at that point. And it's always going in the exact same direction. So it should have like the same slope at the graph at that point. So it's something like that. If I use a little bit more care, this is the line that I'm looking for. I want to estimate the equation of that line. Well, seeing the line, we can actually go directly from what we see. And so, first of all, what does the slope appear to be of that line? And if we can't quite tell, we can see, okay, the coordinates of this point, that's of course 2, -1. And I need another point that's actually on that line. And it looks like this would be a good one up here. That point's at 3, 3. Okay, so what's the slope?
4.
It's got to be 4. So we got y equals 4x, and then we need the y-intercept.
Is it not touching the wood right now?
And again, we can estimate the y-intercept, but it's like way down here someplace. Or we can calculate it. If you calculate it, you should actually get -9. And we get this entirely just from looking at it visually. There's not a magic formula we're using here. It is drawing the line in and then writing the equation of the line we drew.